Whether you need to manage bots, protect cloud applications at runtime, stop form jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly Unlocked will be held in person this December 5th through 8th at the Hilton Lake Buena Vista. We're excited to announce our first round of speakers: Dave Kennedy, Alyssa Miller, O'Shea Bowens, Marina Savada, Patrick Coble, Chris Eng, Eric Escobar, Kevin Johnson, and Justin Kohler. Visit securityweekly.com/unlocked to register and check out our exciting lineup. If you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. Also available for your viewing pleasure is the entire show index of the Application Security Weekly, so please go check that out as well. And while people are loading up that show index page in their browser, there's a couple just a few vulns and such for us to cover for the news this week, John. One of the things that is not a vuln, but is looking for vulns, is this new, renewed PunkSpider. So here is a tool that's going to be re-released, or a new version of it released in DEF CON. And what it is essentially a massive web application scanner that goes out, finds some common vulnerabilities, and then makes them available to anyone who wants to look them up, sort of a Shodan, if you will, for the web layer. And as you might or might not guess, it's stirred a little bit of debate about just what's the purpose or what's the effectiveness of it, what's the intent. And my first reaction to this was more about what is the current ecosystem around web application vulnerabilities look like, and how has that changed as opposed to just updating the code of a scanner to be more parallel, more functional, more performant, etc. And this to me sounds a lot like of a way of, if it's just going for, let's find as many vulns and make those vulns as available to as many people as possible, and then cross our fingers that they get fixed, that sort of sounds like the wrong way of setting up a bug bounty program, if you will. Because if you don't have a way to respond to bugs, or you don't have a way to contact people about bugs, or if you're not contacting the owners of applications who would be responsible for fixing these bugs, there's a lot of things that have the potential to go wrong here. So if the intent is to raise the bar of security throughout the web, I'm not sure this raises the bar. It just kind of kicks the bar a little bit and says, hey, we should do something. Or actually it says maybe, hey, somebody should do something, and kind of walks away from there.
By itself, okay, cool. Yeah, it saves us a bit of work if we want to go pop some sites for those who do that, because we obviously don't. But let's think like engineers. If we're going to put this data out there, I'd love to hear that they're actually going to go back and track those sites and look at them over 3 or 6 months. Do those things that they're publishing get fixed? Is there a timeline they get? There could be a really interesting paper came out of this. But I'm not sure if they're doing it for that or for sales. So I don't know. It's to me, it gets sort of like, the Kinsella roll of the eyes. trademark. It's like I said, it's saving us time, but people can still find them. Okay, I mean, yeah, it's not doing anything really benefiting anybody. Are people going to respond to that and get their stuff fixed? I hope so, but I'm guessing they won't. So,
yeah, I think it's the shrug and move on. I think is going to be my vote for that article because
yeah.
don't have much to add there. But it was definitely in the news and wanted to cover that and just throw out at least our perspective on it for now and what we know about it. On a totally different end of the spectrum, though, is Google. They their vulnerability reward program, aka Bug Bounties, has been around for over 10 years, and they've spent, if I'm going to get my numbers right, roughly $30 million on the program, which, if we're talking about budgets, and you've brought up some articles before about what's the cost to fix vulnerabilities in production, the cost roughly to find vulnerabilities in production is $3,000, just to make the math easy. And so you could say at a minimum, if you're spending more than $3,000 on bugs or on tools or what have you to find bugs, maybe that's not the best investment. If you're spending less, that's probably a good thing. What is missing, what I would love to hear from all of these types of articles, because everybody loves to show off how much money they spent on bug bounties, even though it's not like really a high score wins. But I would love to see some additional information about how much they spent to fix them. In other words, this was an easy fix that took one engineer 1 hour or 10 engineers a week, that type of thing, because I think that will help us a lot more with the idea of what does it cost to secure your software, and maybe just bug bounty programs are a great way to find and fix in production, and the economics works out.
Yeah. I think it'd be fun to see. It'd be fun to see people, the companies that want to publish those numbers about, hey, look how much we've paid. Pretty please, could they go ahead and publish their marketing budget as well for how much they're spending to talk about how much they paid? Because I think that'd be sort of interesting. Just a hint. We're definitely seeing this trend of bug bounties really sort of taken off over the last 12, 18 months. Maggie talked about in a previous segment, Intel at the hardware level with their FPGAs. And I think it's one thing for an Intel to do it, or a Google, or all these big major companies. My worry with these things is the smaller, less sophisticated, or less mature security. Let me say that, rephrase one more time. The companies with a less sophisticated security program that are going, well, we could either fix our bugs, we could find some pen testers to tell us which bugs to fix, or we could just open a bug bounty program. We all say we don't want to do that, but I think there's a relatively good percentage of companies out there doing that on the smaller side. That's unfortunate and worrisome. So, it'd be interesting to come back to the math statement you said there at the top of this, talking about, okay, well, $3,000, what are you getting for it? What are you putting into it? My sense is some of this is it's a new form of hand waving, I think. Like, hey, we've got a bug bounty program. We paid out $10,000 last year. We didn't pay out more, so obviously our stuff is secure. I think we're going to start seeing a false sense of security from that point of view. And I hope it doesn't bite people, but I'm expecting it to. So I think that's going to be interesting to watch over the next some period of time.
Yes, it has a bit of the unfortunately, the sincerity of, we take your security and privacy seriously, opening sentence of many breach reports. But still a good thing, but it needs you need to have a way for your application security team or your developer team to be able to categorize, respond, and triage bugs that come in. You can't just say, cool, we have a bug bounty and we're going to fix the things. You need to have a processes behind it. And an example of a good process is this other article about from Shopify, or about Shopify, and a access token that was leaked that turned out into a $50,000 bounty. So not bad work for what's essentially a little bit of grep work. Not to take away from the skill, the finding of it, but just showing that also bug bounties are often paid by impact as opposed to effort. And speaking of, we take your security and privacy seriously, there's also another phrase, most or all. Not a great phrase if you have to use that when you're describing the impact of a bug on your company, the security of your company's app. So it's a great write-up. It's a great way to demonstrate. One of the reasons I wanted to highlight it too is, kind of speaking of community that we touched on a little bit with Maggie, of how to work with pen test or work with bug bounty researchers, how to have a positive collaboration, and how to basically say from the AppSec side of things, oh wow, this is actually really bad, really embarrassing, but thank you. Here is what we're going to do to work with researchers, and everybody benefits in this case. So I think that's a really good success from there.
And yeah, I'd love to have her back on. There was so much stuff we could dig into deeper. On that one in particular, she went in a different direction when I was asking about, can you start with simulators and how can you start for free with there? And she went off talking about, and I've done it on the software side, like if you have a room of people and like you show them how to break into something and like the eyes light up. So I'm thinking that sort of concept back and bringing it into bug bounty. Well, we've talked to professional bug bounty hunters on here over the last year or two.
Mm-hmm.
I think there's still space also for people to just come in, and it's not quite so much like the button smasher in a video game, but to come in with a lot less sophistication and still make some interesting findings. I think that the heart behind the previous story there, what Google was doing is they're sort of revamping their program a little bit. It sounds like it was a little confusing how that article came out last week, but it sounds like the overall results of it are going to be pretty good. And hopefully it will bring new people into this space, new researchers, new eyes that, we can look at something all day, but every other person comes in with a different perspective, more or less senior. I think that's going to be sort of interesting to see what comes out.
I think so, and actually a good callback to the Google article too, because they were also they're setting up their bughunters.google.com, and they're growing that community. But what was really neat too is they're also providing some targets. So they're describing one Fuchsia OS, which I think I had known about, but completely forgotten, to be honest. So I don't know if it's actually running on anything. But there is new operating system that is basically super compartmentalized. You could call it containerized, but not so much in containers, just compartmentalized of resources. And also Envoy, which is an open source project that, like an edge proxy, used by a handful of tech companies. And so what it is nice is that Google is pointing to some targets to say, don't just keep looking at our Google Docs or trying to find that yet another cross-site scripting in our Gmail or poking around at Android and Chrome. There's a lot of other things out there to look at. So that is, I think, one nice aspect of how they're growing this is they're pulling in a lot more open source projects or just shining that light on them into their vulnerability rewards program, which overall is a good thing. Two more, speaking of bugs, and these are, I don't know if they have explicit bounties behind them, but we had one that was a webmail compromise via email in Zimbra. Now, I don't know this was too exciting about the Zimbra aspect because many people might not just recognize what Zimbra is, but basically it's a webmail, HTTP-based web app to get into your email inbox. And as you might guess, when I say HTTP-based and email, there is a good desire to throw some XSS in there. And this one stood out, one, because once again, like highlighting nice write-ups, and this is a good educational write-up. The other thing that stood out to me for this is that the type of cross-site scripting flaw that they found bypassed the OWASP. They were using the OWASP Java HTML sanitizer, which sounds like it might be good until you get to the part where it's using regular expressions. And in Zimbra, they were using a regular expression to look at these form elements. And one of a common refrain, or maybe not common enough refrain, is that regexes are great for pattern matching, but regexes are not parsers. And you should be parsing and analyzing HTML, not pattern matching it. And in this case is a really cool example of how trying to pattern match against a form tag and where's the beginning, end of that element, How are you handling double quotes or quoted strings in the context? Another throwback to what the things Maggie was saying. It depends. It definitely depends on where your form tag is, and if it's a form tag or if it is an attribute value that just looks like a form tag in some double quotes. And that's essentially how the attack got around some of this sanitizer and was able to trick it into using an HR tag to inject a form action to an arbitrary content, essentially. So nice and clever. Definitely a known technique within cross-site scripting, but a great one that's a reminder for all of you pen testers out there or bug bounty researchers. Take a look at this and see what you can apply in the future for other places that are possibly using regexes for sanitizing or doing any type of input validation on HTML.
Yeah, I mean, it's good for all those aspects, but also, I mean, it's funny. I feel like I haven't had to deal with this personally for a few years, probably because I haven't. But this would be really great to show to. I'm trying to think quickly enough in my head, but not getting there. It'd be really great to show this to people who are trying to build some of these wheels at home by themselves, or in the office. This stuff is so difficult to do right. And what really triggered me there as you're reading it is, they're using the OWASP sanitizer, but still, even with that, there's not, if you don't have all the pieces done right, and talk about let's see how many callbacks we can go back to that last segment. Maggie was talking about as the complexity of your code grows and you hit that, a complexity score 20 or higher. I mean, just the code snippets on here alone with the regex in them are like, they'd be interested to see how those rank on a linter. I know that usually goes off length, but yeah, it's don't do it yourself if you can't, at all avoid it. It's I wish this was easier to do by now, but it's obviously not. So I don't know. It's a good post though. Definitely a good read.
Yeah, good read. And it can be one of those, to riff a little bit on what you're describing too, it could be one of those exercises to say, work with your developers, say, okay, let's build a regex pattern matcher to sanitize and find, malicious payloads that could be, I'm losing my words now, XSS payloads. Mm-hmm. And then go through and show iteratively, here's one type of payload, here's another, here's a slightly more complex HTML, and see how long it takes before that exercise becomes, as kind of intended, a point of frustration that says, maybe a regex is not the best way to do this. Maybe we do need something that is a parser. And I know, and I can't off the top of my head remember the link, but there is a standard that's being proposed for HTML sanitization within browsers to do this type of thing. Because there's also, once you figure out different payloads, there's also browser quirks to deal with. Mm-hmm. And in this day and age, we definitely don't need to recreate the browser quirks of the of the 90s and have them be more consequential and horrible things for our browser security. And that's the most I can take with browser security. I'm dying here. Oh, but you've got one more thing to say, John.
Yeah. Oh, I got a few. There was one article which I don't think I managed to submit yet. F5 came out. I was going to do this as an I told you so, but I ran out of time to go back to my previous I told you so. It was an episode I think you were not on when we had Adrian here. I was trying to make the case against him and one of our guests that modern day, should we be focusing more on web app as a security issue versus legacy from an AppSec point of view? And I mean, this is F5, so it's, I'm not going to call it a fair and balanced report, but F5 and Centa got together. And they're saying that more than half of the largest security incidents are web-based. So, and that's probably including the whole stack, API, and things like that. But where I was going to go with this, back to your point directly, is we've been dealing with this now for HTML's been out for how many years? At least we're down now to, I think there's 3 major rendering engines. Remember right? Between between Chrome, Firefox, and
Safari,
Edge are using, and Safari. I think we're narrowing down those number of rendering engines, which is a good thing because it means there's less things for all those different variations for us to have to try and code against and support and secure. but still it'd be nice to have that standard come out.
Yes, definitely nice. And because Edge already, they were, Microsoft was going with its own, but now they're like, okay, we'll just use Chrome on the inside and, our Edge on the outside for their Chrome. But I didn't want to reuse the word Chrome because that's getting confusing. And everything's confusing. Other things that are confusing are, I think to your point, and maybe this will bolster a little bit of what you were saying there, John, is there is a top list of exploited vulns from CISA. And this is there is an application security angle here in the sense of just look how legacy a lot of these problems are and the type of problems. So the types of devices that are being exploited are a lot of VPN or edge devices, which isn't surprising because that's a touch point on your external attack surface. So why not go after target those? But if you dig into Citrix, Pulse Secure, Fortinet, and the vulnerabilities in there, I'm smiling because in the CISA article we have, you can see there is a .. Yes, some path traversals. And what's also unfortunate, there's not only path traversals, but path traversals to a Perl Perl code, which I'm going to continue to make fun of Perl. That's going to be my editorial stance. But also the idea of that's got to be some legacy code. The same with the others. There was a simple directory traversal to Etsy password. Like that is a simple lack of compartmentalizing how your system is running on, or what file system permissions it can get to. I'm getting frustrated here. I'm losing my words. The same thing with the other directory traversal was just exposing credential information. So it's a lot of things that seem, unfortunately, sadly familiar to an application security checklist. I'll go ahead and use the word, but problems that we've seen for a long time that have known patterns to protect against. And the other aspect I wanted just to highlight from this is the idea that a lot of these vulns being exploited are actually old vulns. There's one all the way back to 2017, then there's 2018 and 2019 represented as well. So, we're going to make a couple more callbacks to Maggie because we want to encourage her to come back on and talk with us more. But she was saying, patch your stuff. Here's an example of not quite firmware, hardware, but on the software side, patch your stuff, because a lot of these vulnerabilities, they weren't new and exciting. They were old and known. They were old days rather than 0 days.
Don't mind my typing in the background on Discord. Yeah, I've got so many ways to go with this. Let's see. So first, while you were talking, I was digging through there. So we got 12 vulnerabilities on this page. Our 12, they look all unique. So 12 CVEs. 4 of those are directory traversal. So of the top 12 issues, according to CISA, 30% are based off of directory traversal in 2020. Let's see, where are we going next on here? All sorts of RCEs. That's sort of fun to see. The 2017 got a giggle from me, as you heard. What's sort of fun about lists like this too? I'm temporarily out of the enterprise security space, and I'm not disappointed about that. Separate conversation, separate long. Love the space, but every year we go through RSA and we see these same vendors. Not these vendors, but the vendors selling stuff. But the thought here on these poor guys that are on this list, can you imagine the amount of AppSec salespeople that are calling into these companies trying to sell them more product? And that's my comment on that one. It's I don't know. Some of these companies are going to a lot of trouble, right? I've worked with most of these, and I know there's good folks at all these places, and it just takes, as we made a few comments now about Maggie talking about bit fiddling, maybe without. I don't think she was saying unexperienced, but I'll say unexperienced bit fiddling. We were just talking about a few minutes ago. All you need is just to blindly come along and poke in the right place on some of these, and you're going to break things in an interesting way. I mean, especially directory traversal, right? Some of these are probably fairly sophisticated, but at the same time, it doesn't take the rocket scientist to do a few .. And this should be made a little more difficult by now. So, I don't know. It's an interesting list. It'd be interesting to put this together with the other guys we were talking about. What was it? The guys that are going and scanning the internet again and coming up with that list for PunkSpider.
Yeah, PunkSpider.
And seeing what I was going to say what percentage are getting fixed how quickly, but we've got a CV on here from 2017. I know where it's going to go. There's another story which didn't come in. Let's see if I've got it in a tab. There is a new, wow, I found it quickly. New vulnerability out last week in Hyper-V from Microsoft, which I believe I found it last week, and I was busy this weekend, so I didn't get a chance to put it in. It's in the virtual switch. I believe it's a breakout. But part of the problem what they're saying about this is the point of the article was Hyper-V, since it's so low in that OS stack or in your application stack, you're not just going to patch that quickly, right? Because you're going to have to do some serious moving things around. If your VMs are mobile and you can move them to another machine without reboot, then you can take care of the host. But if you can't migrate the VM, then you're going to have to take down the VM as well as a host to patch. So a vulnerability like that, it's not a quick fix. It's not a quick just patch and keep going. And that's probably to a degree how we end up with stuff like that 2017 vuln, which is in there. I didn't see what it was in 20. I saw it was Microsoft. I'm just curious, real quick, what is that related to? It is Confluence server. What? No, it's a memory corruption, but it's related to Confluence somehow. That doesn't make sense if you search down in there. Maybe I'm looking. My ability to search could be broken, but it's... No, it's Microsoft Office. Why are they talking about Atlassian?
Yeah, I think you're just getting a little thrown by the way the table is organized, because there was the 4-year-old vuln was in I think the equation editor in Microsoft Office, and there was an Atlassian flaw that was in SSRF. So SSRF strikes once again.
Okay.
As does visual pattern matching versus parsing of tables, as we've demonstrated just now.
I think I'm going to rest my case at remote code executions in equation editors and just stop talking now.
The prosecution rests, and we will move on to some other vulns. Speaking of testing, I did throw an article in there about just testing in general that maybe I'm going to skip any details on, because I wanted to go to this Kernel Pwning with eBPF, a love story, because who doesn't like a good love story? But what was neat about this is I think it's a really cool conceptual throwback to our discussion with Maggie, as well as what we just been talking about here about also complexity and just kind of poking around at software just to see what happens. So here's a researcher who basically said, one, this is a great write-up, a long write-up that gives you two halves of a story, essentially. What is eBPF? I'm not going to be able to say it consistently correctly, but then also what's the journey to finding the vuln and exploiting the vuln. So even if you don't lean towards the exploit side of things, just understanding when eBPF, anyway, it's a security boundary commonly used for syscall filtering. We've talked about it before, and things like containers, those types of security, and protecting at a very granular level what can or cannot or should not be going on within the kernel. In this case, the researcher says up front, I had no knowledge of what this was going into it, and my hope is by sharing a POC as well as the experience developing it, others can get started with exploitation on eBPF. And what's neat about this is that it's a great way to say, hey, here's a particular technology I'm not familiar with. Let me read about it, play around with it, experiment with it a little bit, and just with that attacker mindset or a threat modeling mindset, what could go wrong? And the long story short, long but good story, is that they found a great mismatch, a great misassumption in the way that the sanitizer that's used for this microcode that's being created for these small bits of functions being created, is that there was a mismatch in the way it was handling 32 bits versus 64-bit values. And they were able to leverage that mismatch and get into a privilege escalation exploit. So really cool journey, really cool details into a lot of what's going on within the code, as well as another callback to some of our previous episodes, looking at what the comments said within the code and what those comments were directing towards in terms of assumptions or that magic phrase, "this shouldn't happen." Well, guess what did happen? A misuse of 32-bit and 64-bit values that turned into exploits. So really great write-up, really fun, and hopefully I did it justice in describing it. It's a great article to read.
No, I think you did. I'm not quite sure how I got there, but there was another link to this which I saw last week, so I probably didn't see this post. And the other link, I clicked directly on. I'm like, oh, because they published. I think we heard about this a few months ago. I think we covered it briefly, but the code's out now on GitHub. So I'm like, cool, let's jump into the code for Desploit. And it's just complicated enough that I couldn't quite wrap my head around it to talk about on the show. But I think this write-up looks like a much better way to go about it. So it's one of those cases where this is probably going to help to read the love story instead of trying to dig in directly into the code. Because, I mean, there's a lot of bit manipulation and stuff going on. So, yeah.
Yeah, and what's also the other thing that really is, I think that was really stood out to me is there was also, there was some hand-rolled bytecode in there, and there was the sentiment that's like, yeah, you're going to need to debug this because just like normal software, exploits don't always work the first time either, except maybe the ... which is why I like them. But what's really helpful is that in here the author says here's some debugging, both at some static analysis as well as some runtime debugging to help you through. So it's a great way to follow along basically what they did, and then you could expand that onto new and interesting additional vulnerabilities that you might find within this eBPF stack as well. And it's still pretty dynamic. So the vulnerability that was described here has been fixed, I believe, in April or July. I think a very recent released code update of this. So there's probably some additional things and some attack surface that could be found, and some flaws in the way that the sanitizers are going about and trying to replace dead code and finds when, what is some malicious or some nefarious bytecode that's in here, and how could we strip it out and protect the server from being abused, protect the kernel from being abused.
eBPF is relatively new. And I say it's been out for, I don't want to put a time on it, at least 5 years, probably 7 or 8 is my guess. eBPF, not EBP. And the reason I mentioned that, I know there's no Riley book out. I think I've got a PDF copy, not a physical one. I dig through it occasionally when I need to, but I think this eBPF space is fairly untouched. I know folks started using it in the container side when they didn't want to do what we did at Layered Insight, and they couldn't use a kernel module, so they started trying to use this for securing things. I know there's some other use cases out there for it, but I think it's still fairly limited in the exposure that it's gotten. So not surprised to see this, and it wouldn't surprise me as people start poking around a little further that we might find some more stuff as well. Because I mean, you're compiling code that gets run in the kernel. So yeah, a little sketchy. Not sketchy, but a little hair-raising. How about that?
Little hair-raising. It's definitely one of those security boundaries, or it's one of those areas that's attack surface that is, user influence code potentially going into the kernel, and that's always one of those scary phrases. So if there's another theme for today besides the safety dance, it is the scary phrases. And maybe with that is time to wrap things up. We'll throw it back over to you one more time, John, just in case there was one other article that was on your mind that you want to chat about, and leave us with any parting words.
Apple's, there was a few stories from the big guys that didn't get in. More updates came out from Apple last week, more O days. I think the interesting part about that, just to hit it real quickly, is the number was pretty staggering. It's the 13th O day that's been patched from Apple in 2021. So while we make fun of a lot of the other vendors, it's not just any one particular. There's a lot of companies out that are still struggling to, as they put out more cool functionality and features, there's still a lot of patching that's having to be done of very significant issues. So I don't want to make it look like I'm picking on one vendor. I want to pick on all vendors equally. So there's that.
Pick on all vendors equally. And the same could be said. We were just talking about Google's VRP program, and Chrome has also had an unfortunate slew of a lot of 0 days they've been pushing out updates for as well. So the problem clearly isn't solved, which means that we're going to have plenty more episodes of Application Security Weekly for you to listen to, because there's going to be a lot of problems out there. So please keep listening. You can thank, or I can thank you actually for listening. I can thank John for joining me, and I'm just going to say thank you again, because I'm stumbling all over my words, and I just have the safety dance stuck in my head, and that's all I'm going to sing as we go out here. So thanks everyone again. We'll see you next week on Application Security Weekly.